Hi, welcome to the first lesson of this course. I would like to start by setting some expectations for the course. This course is designed for new PySystem administrators or seasoned administrators who are looking for a refresher on the main PySystem components. We will not cover everything that you need to know as a PySystem administrator. We highly recommend taking one of the public courses that we offer for new PySystem administrators, the PySystem Administration for IT Professionals and the Building PySystem Assets and Analytics with PyAF. These are both 4-day courses that will better prepare you for the role of PySystem Administrator. There's an appendix section in Chapter 6 of the workbook with some additional troubleshooting tools that will be useful for administrators. We'll refer to these utilities in the workbook as appropriate. In this lesson, we're going to go over a high-level overview of the PySystem. We'll look at the different components that make up the PySystem, get a refresher on basic concepts like PyPoints and PyTime, and we'll also talk about the PySystem architecture in this course. The PySystem is a collection of software that collects, stores, and enhances data from your plant and process and delivers it to users who need it. Simply put, the PySystem is everything between the data source and the data consumer. The PySystem software components in this diagram are the PyInterface or connector, the PyServer, and the PyVisualization tools. Interfaces collect real-time data from the data source and send that data to the data archive for storage. Asset Framework is used to organize and enhance the data that you have stored in the data archive. You can use PyVisualization tools such as PyVision, PyProcessBook, and PyDataLink to consume the data and make meaningful analysis with it. Here we see a more complete picture of our simple PySystem architecture. We have a few data sources sending data to a variety of interfaces. The PyInterfaces collect data from the data sources and send them to the data archive for storage. AF can be used to organize and enhance that data. It has an analytics calculation engine that can perform real-time calculations as the data is being received in the data archive from the interfaces. It can also do backfills using historic data. Event frames are used to help capture important process events, such as downtimes or tracking parts of the process that are outside acceptable limits. When those events occur, PyNotifications can be used to alert users about them. Let's get a brief refresher on what a PyPoint is. A PyPoint is any data that has a changing value over time. This is collected and stored in the data archive. PyPoints are process attributes such as tank level, pump speed, server CPU. The PySystem administrator needs to create a PyPoint for each of these process attributes. This image shows the PyPoint attributes that are used by the interface. PyPoint attributes such as point source, location 1, and location 4 information. When this interface starts up, it loads the interfaces with point source of perfmon and interface ID of 1, and it organizes the PyPoints in scan classes based on the location 4 parameter. In this case, our tag has a location 4 of 1, which means that the scan frequency for it is going to be 1 second. Okay, so let's also get a quick refresher on PyTime. So in the PySystem, we have fixed time and relative time. Fixed time is a fixed date and time, which will never change. So when you build a report with a fixed time of 23rd of August, 2015 at 3 p.m., every time you open that report, the fixed time will never change. However, relative time is a date and time that's relative to the current date and time. This is helpful because you can create dynamic reports. So when you build a report with a start time of star minus 15m and an end time of star, this means that every time you open this report, the archive values for the last 15 minutes will be presented to you. The relative time expression syntax is reference time plus or minus offset. The reference time tells us when to start, and the offset tells us how far back to go. So star minus 15m means star now minus, to go back in the past, 15 minutes. This table shows us some examples of relative time expressions. So star minus 1h means 1 hour ago, t plus 8h. T plus 8h means start from today at midnight and then go forward 8 hours in time, which means 8 a.m. today. Finally, let's go over the PySystem architecture in this lab. We have set up a very simple PySystem architecture for this course with one data source, one interface, one AF server, and one data archive collective. A collective is the recommended method for high availability for data archive to ensure that you always have a backup server in the event that your primary becomes unavailable. We have set up 4 virtual machines for this course. PyInt01 is the machine where the data source and the interface are installed. PyService01 is the primary data archive collective node. AF and PyVision applications are also installed on that machine. PyService02 is the secondary data archive collective node. PyClient01 is the client machine where we will be accessing PySystem data from. We'll start using a virtual learning environment in the next lesson.